Alright, welcome to our third video of Unit 4 Thermodynamics. We're going to be talking about the difference between energy, heat, and temperature. Very commonly misconfused. That's not even a word. Words that people commonly confuse with each other, so hopefully you won't after this video. So, we're just going to start off and put a sentence that really answers the difference. Heat is kinetic energy that is transferred between two objects, and temperature is the average kinetic energy in a substance. So it's almost like heat is the amount of energy that is pushed into something, and after you swirl that around, you've got energy dispersed everywhere. Temperature is the average energy in a substance. So it's more the average versus the amount that's put in. So, for example, it's kind of hard to see, but this is basically meant to be two of the same type of substance. They're different colors for I really don't know why. And the goal is the hope is that you can tell these fires are meant to be the same size. Basically, both of these have the same heat. So, same heat, but notice there's more of this and less of this. And thus, that same amount of heat is going to raise this temperature higher than it will this. Basically, with the same amount of heat, you're going to raise the temperature of something small higher than you are going to raise the temperature of something big. Or, here's the difference. You've got basically the same temperature in this case. Water is boiling. But it's going to take a lot less heat to heat up this little beaker than it is to heat up this pot of water, which is why this is on the cute little hot pad and this is over a fire. So this is same heat, different temperature. Same temperature, different heat. And mainly it comes down to the size of what we're trying to show is the bigger something is, the more heat you're going to need to heat it up. So energy is commonly measured in either joules, calories, or calories. Now, yes, I said the same word twice. We'll talk about that. So a calorie, notice that as a lowercase, is the quantity of heat needed to raise the temperature of 1 gram of pure water. That's about that, by 1 degree Celsius. And a calorie with a capital is just 1,000 of the small calories. Now, you've probably heard calorie before, but typically it's on a food label. Notice, however, that's a capital C. So that is actually representing 1,000 of these small little calories. Now, I've told that to many people, and they start freaking out because they think of that as now 25,000 and they feel fat. I'm sorry, if you do that, please stop. Like, that doesn't make sense. Just stop. Like, no. You're not, yes, you are eating 25,000 of the small calories, but no one really cares. If you want to make someone freak out, go tell them they're eating 25,000 and watch them freak out. It's kind of funny. But, again, just stop. So anyways, though, joules, calories, and calories. Our main two are going to be joules and the lowercase calories, but we will use bigger calories every now and then. Kind of like Fahrenheit compared to Celsius and Kelvin. A joule, however, is our most common one. It is actually the SI unit of energy, but its definition's a little weird. I'm going to tell you it now. Try to remember it a little bit. In AP, we use it a bit more. In physics, you use it even more. But it's the energy transferred when 1 newton of force, it's actually the SI unit of force, is applied over a distance of 1 meter. It basically is the energy required to, I don't remember exactly what it was, I'm sorry, but it's a newton of force over 1 meter. And so these are its actual units. Again, you don't need to worry about those too much. If you can, please try to remember joule and something about kilograms. That'll actually come in most handy in AP Chem. Just try to remember that a bit. And if you don't, it's okay. I'm not going to actually ask you to define that or anything on the quizzes or tests this year. Next year we will a little bit. Anyways, to convert between calories and joules, really this is all you got to know. The 1 calorie is equal to 4.184 joules. So if you got joules, divide them by 4.184. You've got calories, multiplying by 4.184. This is actually more of a conversion factor than a formula. So, yeah. Alright, to convert the given amounts to joules and calories, we will need that previous conversion factor I showed you. As with before, I'll do the first one, give you some time to do the next 3, and then I'll work through the last ones with you. So for our first one, we have 42.5 joules. We're going to calories. So calories on top, joules are on bottom because we want to cancel out joules. And we know that 1 calorie is equal to 4.184 joules. That gets us 42.5 divided by 4.184, which is equal to 10.2 calories. And that's it. I'll actually show you the second one. Just give you a little bit more practice. They're not hard, but I have the answer here, so might as well work with it. So the second one is 19.7 cal. We're going to joules, so 4.184 on top, 1 cal on bottom. Multiply that together, and you will get 82.4 joules. Alright, so have fun with the next two. Go and pause the video, work on them, and press play when you're done. Okay, hopefully you're ready to move on. If not, I don't know why you press play. So press pause and finish. So, 99 joules. Going to cal. We got 1 cal. 4.184 joules. Multiply those together. You get about 24 cal. If I'm rounding differently, I'm keeping sig figs. So 2, 2. That's why I'm rounding a little weird. The fourth one's actually the weirdest. But again, if you're pretty close to 24, you're good. I recommend keeping sig figs, but I'm not going to really require that too much. For our last one, 32. Nope, sorry. 4.184 joules over 1 cal. Actually should be a cal here. Multiply that together, you get about 134 joules, which actually sig figs technically is 130 joules. Both are fine though. I'm just trying to get used to using sig figs. That's it. So again, hopefully you can convert between joules and calories, and you also know the difference between energy, heat, and temperature. Here's some practice. So these, convert them to the different unit, and then for 2 of the above measurements, also convert them to actual calories with a capital C. But as always, thank you for watching. Have a good day, and yeah.